Hi everyone, I'm Marin, I'm a software engineer at Birdie, and today I'm going to tell you the story of how we made our app 80% faster. It's a data structure story, but it's more than that. It's a happy story of massive performance improvements, but it's also a cautionary tale of lacking performance monitoring and also a whole bunch of other mistakes we've made. This is all about many mistakes we've made, what we learned from it, and how we had this massive improvement in the end. I hope this story will be entertaining and that you'll learn something from it. As all good stories, it's in 3 chapters. And because I know that's the main thing you're waiting for, the one thing that's improved our performance by 80% is in the 3rd chapter. So let's move on to the first one and start from the beginning. So first, how did we get here? Well, I'm going to talk a little bit about Birdie, what we do and all that, just so that you have enough context to understand really the pain points we run into. So first, what is Birdie? Birdie is a company trying to make our world a world in which we all age vibrantly and with confidence. So in whatever way we can, we try to improve the lives of older adults in their own home. The way that works currently is we provide software to home care agencies so that they can visit older adults in their own homes and take care of them. What that looks like is a web app that you can see on the right that is used by care managers and agencies to plan visits, medications, tasks, all sorts of things that needs to be delivered during these visits. And here we can see snippets of the mobile app that is used by carers when they go to the client's home and deliver the visit. So let's briefly go over what the UX looks like, the user flow for a carer going to a visit. First, they will see all the visits they have planned for that day. They will select one, go to a client home, do a geolocation check-in. Then they will see all the tasks and medications they need to deliver during this visit. For medications, we have some more forms with multiple stages in there so that they can record multiple types of observations and those sort of things. Then they can see when everything is done. They can also record some extra observations for other medications that day. They can check information about past medications for that person that day. That's useful when, for example, you want to check that the last time a medication was given, it wasn't like too close to now that you're trying to administer it. All of these safety features that are very important because this app is really critical. If you overdose or if you miss a dose, it can really have dramatic consequences. And finally, they can record all sorts of observations about what happened during the visit, what they observed about the older adult, the client they're taking care of. All of this flow, it has lots of data, and all of it needs to be on the device because it's all offline first. Because, well, they sometimes have to visit clients in the countryside with very low signal area, and we want to make sure that all of those critical features work offline. Another interesting point, this talk is about performance, and for many performance talks, it's usually about keeping your users engaged, keeping them on your app as much as possible by having a great user experience. Well, this time, it's the other way around. For us, good performance means that they take less time spent on the app, and they can take the time to really take care of their clients in their homes. So we want to get out of the way of what they're doing. Now, this great mobile app, it was Birdie's first product. It's a bit more than 4 years old now, actually. So it's all based on mostly 4 years old React Native stuff. And after all this time, and after building lots and lots of features on top of it, we end up in a situation with, well, pretty bad performance, as you'll see more of it later, which is due to many things, but one of the reasons we got there was because our engineers they work on their own devices, which are mostly powerful devices, or on emulators, which doesn't represent accurately real-life performance on real devices. We also had barely any tooling for monitoring our performance, and we have very indirect feedback for performance issues, because the carers are using the app, and so for us to know about a really bad performance issue, it means that the carer has to be frustrated enough to complain to their managers, who are paying for Birdie, who will then complain to us, and that's when we start looking into things. And then, after 4 years and many teams working on many features, we had a massive, very complex code base, and as I said, it's very critical, so we have to make sure we don't break anything every time we make changes. So quick recap of chapter 1. We have a 4-year-old care delivery React Native app. It's slow, and we don't know why. That's the stage for our story. Now, let's all embark on this magnificent journey. Chapter 2, a journey into the unknown. So we have this slow app. We don't know why. Our first assumptions was, well, for 4 years, we've been building lots of features without really looking into performance that much. So maybe it's just thousands of performance paper cuts, lots of little things we just didn't take care of. And so when we're not experts in React Native and we have this problem, we turn to the best expert we know, the internet hive mind. So we looked on Google for React Native performance tips. We tried many things. Among those things, we reduced all the useless re-renders we had everywhere in our app. We didn't have proper lists, so we moved to virtualized flask lists to have better performance there as well. As we saw for medications, for example, we have forms with multiple stages, so we started freezing our navigation stack to avoid lots of re-renders in the background, and many more things like upgrading dependencies and a whole bunch of stuff, hoping for the best. Now, after all that, after months of improvement, it was a little better, but still bad. Now, you might be wondering, how much better? How bad? Well, who knows? We didn't have any tooling, so all we could do was trying it out ourselves and see if it was better. It was really hard to quantify the difference it made. Now, after that, after a bit more manual testing and a lot more experimentation, it was really clear that it was a scalability issue. Now, what do I mean by scalability? It means that each of the care agencies have their own environment, and a big agency made the app slower, which means that we seem to have a link between the number of clients in an agency and how bad the performance was. So once we got there, we looked at what are all the things, all the data we're handling that is scaling up with the number of clients. So we had the client infos, like their profile pictures, their name, all of that. We had user permissions. Those are permissions we use to control features that are enabled or not for an agency or for a specific client. Visit reports, because whenever you deliver a visit, you create a visit report and you can see previous visit reports to see what was done before with this client. And finally, the client tasks. So all the things that you need to deliver during a visit. Actually, we download all the tasks and medications for that day for all the clients you are assigned to, because sometimes you just need to go and deliver an unscheduled visit, we call that. And so you need to be ready to be able to deliver those even if you're offline. So that's actually a lot of data. And we figured that in the biggest agencies, that was tens of megabytes of data that kept moving around and kept being handled in our mobile app. So we focused on that. And by doing a little bit more experimenting, we made a new assumption, which was that maybe we just had too much data going through the bridge. Now, let me explain a bit more. Quick recap of the bridge. We have the JavaScript side of things, we have the native side of things, linked by the bridge with JSON. that's about it. That's all you need to understand from this section. We use Redux in our app to manage all of this data that I just talked about, and for our app to keep working fine if the app crashes or whatever, and you need to keep all that data, we use Redux Persist. Redux Persist, the way it works briefly is whenever you have a new action going through your Redux state, updating your Redux state, it will persist it on the device, so that then when you open the app again, however it was closed, it can get back this data without having to refetch it. And in our case, we had an issue because, as I said, we have many, many tasks. And whenever you just try to complete one, well, you're actually updating the entire task state, and all of that has to be updated and persisted, which means in our case, Redux Persist, it has to turn everything into a string to get stored on the device, which means that on almost every action related to task, we had to stringify a massive array of tasks, and yeah, that was expensive, pretty bad. We could see a big stringify thing on our graphs when we looked it through React Native Debugger and those sort of profiling tools. So we were sure this was the issue. And so we looked at multiple solutions, and one that looked pretty good to us and we focused on was a tool called Watermelon DB. So if you haven't heard of it before, it's a cool tool that's based on an SQLite database that is on the device. And then it uses a pattern called observables to update your components based on changes on that database. So we would basically replace Redux and Redux Persist by this SQLite database that is on the device. Which means that now we're not stringifying an entire task full of state full of tasks. We're only stringifying the query we're doing to update our task, which means that whatever amount of tasks you have stored on your device, it's still the same amount of data that needs to be stored and exchanged. Now, sounds like the perfect solution. How did it go? Well, first, it was actually a lot of work to get it working, because it wasn't a greenfield project, almost the opposite of a greenfield project. So trying to get both Watermelon DB and Redux to work together meant that we had to create this new concept of observable selectors, which meant that on the same component, you could use the two and have your UI update at the same time. Actually, if that interests anyone, if that could be useful to anyone, we'll be very happy to work together to make it open source and useful to anyone. Feel free to reach out. Once that was done, turns out that all those observables patterns didn't really work with a lot of our legacy code, which meant that we had lots of bugs. So yeah, that was not a great solution. Oh, and worst of all, it was still slow. Yeah. And why was it slow? We still don't know. No idea, because we still didn't have tooling. That's when we learned our lesson and introduced performance monitoring. We went with Datadog RUM for this, which is a real user monitoring tool. It was first for the web, but now it works with React Native as well. And so we introduced this, and that way we were sure we were able to measure the changes we've made to performance things in our app. Now, when we saw all that, our next assumption was that maybe this strategy of downloading all this data, all those tasks, maybe that was just too much data. So we went with a UX change rather than an underlying technological change. And we looked into introducing manual download of tasks rather than downloading everything by default. And that looked pretty much like your video or music streaming app with a button on the right that allows you to download the task for the client you want. And that way, if you don't have a specific planned visit for that client, but you know you might visit them later and you will be offline, you can choose to download it. And that way, the amount of tasks stored on your device wasn't linked to the amount of clients assigned to you on an agency, which meant that this would become scalable again. We introduced this change on some test agencies that we had with many, many clients. And this time, we were able to measure it. So, what was the result? It was still slow. So all of this took months, each iterations. And now that we're here, let's just have a quick recap of this chapter 2. We tried many React Native performance tips. We tried a more scalable data management. And we tried just reducing the amount of data, of tasks. And it's still slow. So what is the issue? Why is it slow? Well, it's time now for chapter 3, the big reveal. Let's go back to all the data that scales with the amount of clients we have. So we now know that it's not the client tasks, because it doesn't make a difference in performance. Now, what else do we have? Visit reports. Well, from what we've seen on our test agencies, some of them have many clients and almost no visit reports, and some have the other way around. And there doesn't seem to be a correlation there, so it doesn't seem to be visit reports. Client infos, well, we're not manipulating that a lot, and it's barely any data. It really doesn't seem like a good candidate. That leaves us with user permissions. What about user permissions? Let's maybe look a bit closer at what those user permissions look like. Turns out they're pretty bad. Oh, sorry, that's ugly. Yeah, that's as bad as it looks. It's a massive array of strings, just no structure, just that's it, an array of strings. And that was introduced when we launched the app about 4 years ago. And we had 15 permissions per user, approximately at the time. Turns out that 4 years later, we have more than 10,000 per users. So yeah, that's why this is bad. Especially because those permissions are in our Redux selectors, in many, many of our components, pages, all of that, because every time we load a page, we see how should it be displayed, what should be displayed, etc., etc. Now let's take a closer look at how those permissions are structured. As we can see, there's 2 types of permissions, agency levels 1 and client level 1, where it's just agency and the permission, like here managing caregivers, or for a specific clients. CR means care recipient, so we know it's for a care recipient. We have the client ID and then the permission, like in this case, downloading a PDF of their info. Well, looks like we can change the structure, and we did a very simple change. We just turned this array into an object, where now, when you're looking for the permission for a client, it's not n anymore, with n being up to 10,000 permissions. It's just O1 to find your clients, because you know already which key you're looking for. And then you're just looking through an array of up to 10 permissions. I can hear the irony of us in the past assuming that 10 permissions was fine, so it's not the perfect solution. But still, we introduced that, and let's see what impact it had. So with a quick before and after of switching agency, which actually resets everything in our app. So here, the after is already done after like 4 seconds, and the before takes 40 seconds. And that's on our biggest test agency that we use to test those types of scalability issues. I don't know if we're going to wait for that one, actually. It's pretty bad. Now, how do we know, other than by looking at it, that it was improved by 80%? Well, thanks to our cool new tool, of Datadog RUM. Datadog RUM has some mobile vitals that can be used to assess performance of your app. For example, frames per second, CPU usage, memory usage, frozen frames, all those things. And so here we had 2 sessions that were recorded, as you saw, and it was clear that one of them was really bad and the other was fine. And when looking at those vitals, there were no difference. So yeah, that was a bit frustrating as well. So what we did is we added some more custom tooling. We started instrumenting Redux itself by adding all of our Redux selectors, reducers, Redux sagas as well in our monitoring of Datadog, which meant that we had cool graphs like this, where on a single page we could see what the user did, but also what happened in the background, which selectors were used, how long did they took to get data, same for updating the state with reducers or getting sagas to run, etc., etc. And what did we find with this? Well, here we looked at the average duration of Redux processes after our permission update. And as you can see, it was massive. Up to 92% decrease for selectors, 90% for reducers, 64% for sagas. Here, we finally found it, our bottleneck. We also looked at specific devices. Here at the top, we have a low-end Alcatel, then a mid-range Nokia, and a high-end Samsung. And as we can see, the biggest impact was on low-end devices, but still a very noticeable impact on high-end devices. And that's it, a happy ending. Finally, we fixed our performance issues. But I actually don't think that's the most important thing. The most important thing is, what can we learn from all of this, from this story? Well, let's wonder, why did it take us so long to find the issue? Well, the first mistake we made multiple times was that we mistook other issues as the main performance bottleneck. We found a performance issue, and we assumed that was the issue, so we just jumped straight at it and tried to fix that before trying to compare what was going to have the biggest impact. In particular, well, we were blinded by what I call the big stringify, which was an issue, but maybe, well, in this case, not the biggest one. In general, we were blinded by tasks just because it was the biggest part of our state. And yeah, we just jumped straight at it without looking at a bigger picture. So what are the learnings from it? Well, first, you need to validate your assumptions before investing in solutions, especially if they're expensive, take time, etc. Then performance improvements without tooling is a guessing game, and it's a game that you're not likely to win. So invest in tooling and monitoring. It will make your life a whole lot easier. Now, a classic, the one we learn about the first time we read the Redux documentation. So Redux selectors are bad. They have a really big impact on user experience, as you were able to see. And finally, a classic, just in general, when we tend to just look at high-level programming concepts, just data structures and complexity matters. It's, especially when you scale, it has a massive impact. And that's it. That's the end of our journey, of our learnings. I hope it was entertaining. I hope you learned something. You can contact me on Twitter, LinkedIn, mail. Everything is on mycar.co. I'm a software engineer at Birdie. Now we know what we do. You know what we do. We're still learning, still growing, hiring. And yeah, feel free to contact us if you want to work with us. And yeah, that's it for me.